Find the value of 1 minus 1 by 2 square whole multiplied by 1 minus 1 by 3 square whole multiplied by 1 minus 1 by 4 square. Like this multiplication goes up to 1 minus 1 by n squared. The problem is simple if you recognize that 1 minus 1 by 2 whole squared is equal to 1 minus 1 by 2 multiplied by 1 plus 1 by 2. That is 1 minus 1 by 2 squared is equal to half minus 3 by 2. Similarly, 1 minus 1 by 3 squared is equal to 1 minus 3 multiplied by 1 plus 3, and that is equal to 2 by 3 multiplied by 4 by 3. 1 minus 1 by 4 squared is equal to 1 minus 1 by 4 multiplied by 1 plus 1 by 4, and that is equal to 3 by 4 multiplied by 5 by 4. So on and so forth until 1 minus 1 by n square is equal to 1 minus n multiplied by 1 plus n, and that is equal to n minus 1 by n multiplied by n plus 1 by n. Therefore, if you write out the whole series at one time, that is 1 minus 1 by 2 square multiplied by 1 minus 1 by 3 squared multiplied by 1 minus 1 by 4 squared multiplied by 1 minus 1 by n squared is equal to half multiplied by 3 by 2 multiplied by 2 by 3 multiplied by 4 by 3 multiplied by 3 by 4 multiplied by 5 by 4 dot n minus 1 multiplied by n minus 1 divided by n multiplied by n plus 1 divided by n. You notice that the in-between numbers get cancelled out from different terms. I have shown that with red cross marks. Therefore, whatever is left is the first term 1 divided by 1 by 2 and the last term n plus 1 divided by n. So it is like this, and that is equal to n plus 1 divided by 2n. Since all the intermediate factors cancel out, we get the answer as n plus 1 divided by 2n. Now, I am going to do another problem in this video because this was a very short video. So please stay, do not go away. The next video will follow. Before going on to the second video, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it to your comments. Without further ado, let's proceed to the second video. The second question is, what is the exact value of sine 3 theta plus sine theta divided by sine 2 theta multiplied by cos theta for all values of theta such that the expression is defined? The numerator of the given expression is sine 3 theta plus sine theta. Now sine 3 theta is sine 2 theta plus theta, and sine theta is equal to sine 2 theta minus theta. Therefore, sine 3 theta plus sine theta is equal to sine 2 theta multiplied by cos theta plus cos 2 theta multiplied by sine theta. These two is equal to this sine 2 theta plus theta. Similarly, sine 2 theta minus theta is sine 2 theta multiplied by cos theta minus cos 2 theta multiplied by sine theta. And if you add these two things up, the term cos 2 theta and sine 2 theta, they cancel out. Therefore, we are left with sine 2 theta plus sine 2 theta multiplied by cos theta plus the same thing again. Therefore, we get sine 3 theta plus sine theta, that is the numerator, is equal to 2 sine 2 theta multiplied by cos theta. Therefore, the given expression that we are given to evaluate, that is sine 3 theta plus sine theta divided by sine 2 theta into cos theta, is equal to 2 sine 2 theta multiplied by cos theta divided by sine 2 theta multiplied by cos theta, and that is equal to 2. While the answer is straightforward, we have to keep in mind that for some values of theta, this expression is not defined. This happens when the denominator becomes 0. That is, when theta is equal to 0, sine 2 theta becomes 0. Since sine 2 theta is appearing in the denominator, the expression will become undefined. Similarly, when theta is equal to 90 degree, cos theta will be 0, and since cos theta appears in the denominator, the given expression also will become undefined. Therefore, when theta is equal to 0 or when theta is equal to 90 degree, the denominator becomes 0 and the given expression cannot be evaluated. So, those are the considerations. Thank you very much.